So, have you ever looked at Wall Street and wondered, how in the world do they put an exact price on something as tricky as a bond? I mean, interest rates could go up, they could go down, so how do you know what you should pay for it today? Well, today we're going to pull back the curtain on one of the most important ideas in modern finance, the arbitrage-free valuation framework. Here's how we're going to break this down. First, we'll tackle the central puzzle of bond pricing. Then, we'll get into the one unbreakable rule that guides everything. After that, we'll actually map out the future. And then, this is the cool part, we'll work backward through time to find the bond's true price today. And finally, we'll see why this whole idea is the bedrock for pricing almost everything in finance. All right, let's get right into it. The bond pricing puzzle. At its heart, we're trying to answer a really fundamental question. In a world that's always changing, what is a bond really worth? Let me just ask you that directly. Imagine you've got the cash. You're ready to buy a bond. What's the one single, correct, fair price you should pay for it? Right here, right now. It seems like a simple question, but the answer is anything but. Okay, first, just a quick refresher so we're all on the same page. A bond is basically just a fancy IOU. You loan money to a company or a government. In return, they promise to pay you interest along the way, we call those coupons, and then at the very end, they give you your original loan amount back. That's the par value. Simple enough, right? Well, here's the twist. If interest rates never changed, this would be easy. You just figure out the present value of all those future payments. But rates never stay fixed. They go up, they go down, and every single time they move, the value of that money you're expecting to get in the future also moves. And that uncertainty, that's the puzzle we have to solve. So, how do we solve a puzzle like that? We need a guide, a fundamental law of the financial universe that keeps everything in check. And that law has a great name, the no arbitrage principle, or as I like to call it, the no free lunch rule. You gotta love this principle because it's so simple and powerful. All it says is you can't get something for nothing. If two different assets promise the exact same cash in the future, they must have the same price today, period. If they didn't, you could just buy the cheap one, sell the expensive one, and make risk-free cash. And the market, well, it just doesn't allow for a free launch like that. Okay, so if we can't ignore the uncertain future of interest rates, what do? We map it out. And the map we're going to use is called a binomial interest rate tree. Now, don't let that fancy name scare you off. A binomial tree is just a really simple model. It assumes that at any given moment, the interest rate has a choice. It can go up or it can go down. That's it. And by linking these simple up or down choices together over time, we can build a map of every possible path interest rates could take. It's kind of like a choose-your-own-adventure for money. All right, this is where the magic really happens. To figure out the price of the bond today, we're not going to start today and look forward. Nope. We're going to do something that feels a little weird. We're going to go to the very end of the bond's life and work our way backward to right now. And this formula right here, this is our time machine. It looks a little complex, but it's not. It just says the value at any point on our map, any node, is the coupon payment C that you get at that spot, plus the average of the two possible values the bond could have in the very next step. Then you take that whole thing and discount it back by the interest rate I at that specific point in time. We're just averaging the future and pulling it back to the present. Okay, let's do this. Step 1, we start at the only place where we have 100% certainty, the very end, at maturity. We know for a fact the bond is going to pay back its $100 par value plus that final $5 coupon. So its value is $105. No question. All we have to do is discount that guaranteed $105 back 1 year using those different possible interest rates from our tree. And just like that, we know what the bond is worth at every possible point just before it matures. Now we take our first step back in time to year 1, and we'll start with that upper path on our tree. We just use our formula. We take the $5 coupon for that year, add the average of the two future values we just calculated, and then we discount that whole sum back using the 5% interest rate that only exists at this specific spot. And bam, there's our answer, 98.2280. So what is that number? That's the fair price of the bond 1 year from now if interest rates took that higher path. See, we just solved one piece of our puzzle. Now we just repeat the process for the lower path at year 1. It's the exact same logic. We take our $5 coupon, we average the two future values that are connected to this node, and we discount it all back using the lower 3% interest rate. Same method, just calculating for that other possible future. And that gives us 101.9506. Okay, this is great. We now know the value of the bond for every possible scenario 1 year from today. We're so close. We're ready to take that final step back to the present. This is it, the moment we've been working towards. We have journeyed back from every possible future, and now we are standing right here at time zero, ready to find the one single fair price for today. We use our formula one last time. We take the $5 coupon we get today, we average the two possible values for year one that we just figured out, the 98 and the 101, and we discount that whole thing back using today's interest rate, which we know is 2%. This one calculation ties our entire map together. And there it is, 103.0287. Now that's not just a good guess. That is the only price that works. It's the one price that guarantees there's no free lunch no matter what path interest rates decide to take in the future. That is the arbitrage-free value. The puzzle is officially solved. So, okay, we've walked through this little example with our tree, but why does this framework matter so much in the grand scheme of things? Here's what you should really take away. First, this gives us a totally consistent, logical way to price things even when we don't know the future. Second, it's all built on that incredibly powerful no free lunch idea. And maybe the biggest takeaway of all is that the simple logic we just used, mapping out the future, preventing arbitrage, and working backward, that's the exact same logic used to price the most complicated financial instruments in the world, in a market worth trillions. You know, the little tree we built? That's just the training wheels. In the real world, this idea evolves into incredibly sophisticated models, like the one you see here. Yeah, it looks super intimidating, but deep down, under all that crazy-looking math, is the exact same engine we just used. Map the future, forbid any free lunch, and work your way back to find today's fair price. And that kind of leaves us with one final thought to chew on. This entire framework is designed to find a price that makes sure there are no easy, risk-free profits just lying around. But that raises a much deeper question, doesn't it? If the price perfectly eliminates the chance for a free lunch, what does that price truly tell us about the nature and the cost of the risk we are actually paying to take on?